The first section we're going to look at in Chapter 10 is about solving quadratics using square roots. So by the end of this lesson, you should be able to identify what a quadratic equation is and then solve them by taking square roots. So let's talk about what a quadratic equation is. A quadratic equation is an equation that can be written in the form of ax squared plus bx plus c. If you remember when we talked about polynomials, anything with a degree of 2 equals a quadratic. So far in this class, we have only solved things that have a degree of 1 because those are linear. And you'd get problems that looked like 3x plus 2 equals 4x minus 6. And you could solve that, and you could tell me what x equaled. We're going to be doing that now with quadratics. So this square right here changes everything. And when it's written like this, it's called the standard form of a quadratic equation. Because again, if you remember about polynomials, standard form means that you take the exponents and you order them from least to greatest. So it goes 2, 1, 0. A quadratic equation can have 2, 1, or no real number solutions. In a future course, you will learn about solutions of quadratic equations that are not real numbers. These are called imaginary numbers, and if you've ever seen anything with them, they have an I next to them, like 3i is an imaginary number. But that's Algebra 2, so all we're going to deal with are real number solutions, numbers that you guys know about. The solutions of a quadratic equation are the x-intercepts, and they are also called the roots or the zeros of the function. This right here is really, really important, that the solutions are the x-intercepts. And if you take a look at these graphs in a sec, that'll make a little more sense. There are 4 different ways that we're going to use to solve quadratic equations. We're going to do the first one today with square roots, and then we'll do factoring, completing the square, and quadratic formula later. So if we take a look at all these equations, it's easy to see how there can be 2 solutions, 1 solution, or no solutions. So if we take a look at this equation right here, x squared minus 4 equals 0. If I told you to solve for x, hopefully what you would do first is add 4 to both sides, and then you'd have this. And if you took the square root of 4, you would end up with 2 solutions that would make this work, positive 2 and negative 2. And that's really important to remember because when you have this equation, there are 2 things that you can square that will give you 4. 2 squared obviously gives you 4, but so does negative 2 squared. So when we get 2 solutions like this, those are our x-intercepts of this equation. If I were to graph it, it's going to cross at negative 2 and at positive 2. But in an equation like the next one where x squared equals 0, if I wanted to solve that, all I have to do is take the square root of both sides, and I get x equals 0. There's no positive 0 or negative 0, so there's just one solution, and it's right there where it crosses the x-axis. And then sometimes you're going to get equations like this. When you go to solve, we'll get x squared by itself, and then we can take the square root. You cannot take the square root of a negative number. It's not allowed. If you try typing that in your calculator, it says error. So when this happens, there are no real solutions. And like I said before, you'll learn in Algebra 2 that there's something called imaginary solutions here, but for right now, if you have to take the square root of a negative, you just write no solutions. So remember, when you're solving with square roots, some of the problems can get a little more difficult, but your goal is to get the squared thing by itself and then take the square root of both sides. So we're going to skip A because we just did problems like that, but let's look at B. If I want to solve this, I need to get n squared by itself. So I'm going to subtract 12 from both sides. And then I have to still get n squared alone. So I want to divide by 3. And if you do 0 divided by 3, you just get 0. So then all I have to do is take the square root. Whatever you do to one side, you got to do to the other. So we only end up with one solution here, which is totally fine. That means it would only cross the x-axis once. But if we try one like the next one, the steps are the same. You gotta move stuff around to get the squared thing alone. And then divide. So we get g squared equals negative 16. So now if we go to take the square root of both sides to get g alone, I notice that I'm taking the square root of a negative number, and that can't happen. So we write no solutions. So let's try a story problem. The city planner is planning a circular fountain. The depth of the fountain will be 3 feet, and the volume will be 1,800 feet cubed. Find the radius of the fountain. So we have the circular fountain. If you remember the formulas for any of this stuff, that will come in handy. You have a radius here, and then you have a depth. So the area of the circle is pi r squared, and then we got to multiply it by how deep the fountain is. So pi r squared times depth is going to be the formula for this. So plug in what we know. We know the volume is going to be 1,800. Pi is just a number. We're looking for the radius, and then we know the depth is 3 feet. So we have to get the squared thing by itself, just like we were before. So let's divide both sides by 3. So we get 600 equals pi r squared. And then remember, pi is just a number, so let's divide. And if you throw this in your calculator, you can get an approximation of this, or we can just leave it as 600 over pi for right now. Because then we're going to have to take the square root of both sides, and we can actually type all of that into our calculator and get a much more exact. So we can type in all at once that we want to take 600 divided by pi and then take the square root of that. And you end up with about 13.8 feet. It's going to be our radius. So you should be able to identify a quadratic equation. I want you to give me an example of a quadratic equation and then give me a non-example. And then I want you to solve these two things and answer this question right here. If you have any questions, make sure you write them down and we can talk about them in class tomorrow. Enjoy your night.